Our tap crossed the whole internet and got handled. But everything we built leaned on one thing in the shadows, the database, where the truth lives. And here is the finale. Almost everything else on the internet is easy to scale compared to the database. When your game explodes to 50 million players, this is the part that keeps engineers awake. Why so hard? Servers can be cloned, but data cannot. 10 copies of your player service are interchangeable, but 10 copies of a database that all accept changes quickly disagree about the truth, and now which copy is right? So we scale in stages. Stage 1 is obvious. Buy a bigger machine. More memory, more CPU, more disk. This is vertical scaling, and it works for a while. But there is always a biggest machine money can buy, and 50 million players will blow past it. The ceiling is real. So stage 2. If one machine cannot do it, use many. But many writable copies disagree. So the first trick keeps one boss. A single primary accepts all writes, and you add read replicas that stream from the primary and answer only reads. Most apps read far more than they write, so this alone is huge. Reads hit replicas, the primary handles changes. If this sounds familiar, it is the exact replication idea from our Redis and Kafka series. One writer, many readers. But replicas share one wall. Every replica still holds the entire dataset, and every write still funnels through that one primary. 50 million players is too much data, and too many writes for one primary. Pause and think. If one box cannot hold all the data, what is the only option left? You split the data itself. This is sharding. Instead of one giant database, you run many, each holding a slice. Players A to M on shard 1, N to Z on shard 2. Each shard is its own smaller database with its own primary and replicas. And now you've seen this idea 3 times on this channel. Cassandra spread data with a ring. Kafka split topics into partitions. Redis carved keys into slots. Databases shard by key. Different names, one deep truth. To grow past one machine, split the data across many and copy each piece for safety. But sharding is costly. Cross-shard questions get harder, and a bad split key wrecks you. This is why data is the hard part and the last thing we scale. So let us zoom out. Your tap became a number through DNS. A load balancer chose a healthy server. A CDN served images from nearby. An API gateway checked who you are. A queue absorbed the slow work so nothing froze. And underneath it all, a sharded, replicated database held the truth. That's system design. Not one clever trick, but many simple ideas, each solving one bottleneck stacked into something that serves millions. So here's the big picture, the whole series in one breath. The internet is layers of simple ideas. Spread the load, cache what's hot, guard the door, defer the slow work, split the data. You can now look at almost any large system and recognize the pieces. Our single tap completed its journey across the entire internet, and you watched every step. That completes the series. Tell us in the comments, which of these boxes should we crack open and sketch next?